Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So in the previous class students, we had studied relations and functions of class 12th, and I think we had covered the types of relation and also introduction to function. So in today's class, we'll be starting with types of functions. So these are contents for this session. All right. So one function, many one function, onto function, composition of a function. So these four, okay, we'll be covering it in today's session. So there will be only two more topics, okay, which will be done in the next session again. Only two topics: invertible function and binary operations. So what are these? These are nothing but the 4 points whatever I have written here. So these are nothing but types of functions. So we'll start looking at one by one function, many one function, onto function, and so on. So before we start with one function, let us see just what is function. So function, how is it represented? Function is represented as f of x, correct? And y will be equal to f of x. So f of x means any function of x. So for example, y is equal to x square plus 1. So this is a function of x, correct? So now if you input x is equal to 1, so that is the domain. So 1 if you input in the place of x, 1 square is nothing but 1 only. 1 plus 1 is 2, so 1 comma 2. So what is very special? Function is also a relation. What is very special about the function is, for each value of x, there will be only one value of y. Okay, so 1 will be having only 2. Again, you cannot write 1 comma 3. So this is not possible in function, because 1, if you input in the place of x, if you input 1, you will be getting the output as 2. Okay, again if you write 1 comma 3, this is wrong, then this will be called as a relation. Alright, so we'll start with the types of functions now. The very first one function. So this is also called as an injective function. Very simple, students. So in a function we have, so we'll take the mapping here. Okay, mapping of the function. So here we'll be having the set of x values, okay, which is called as domain, which is also called as pre-image. Okay, so on this side we'll be having a set of y values, which is called as codomain. It's nothing but called as image as well. Okay, codomain or image, domain or pre-image, like that. Now from here to here, what is happening, students? Here to here there is a function f. So how is this f defined? So let us write f of x equals 2x. Okay, so here we'll write 1, 4, 6, 8, 10, 12, 14. Okay, so on this side we'll write 1, 2, 3, 4, 5. Now see what is happening. We'll change the color here. If you input in the place of x, if you input, okay, so here we'll also write 2 here. Okay, so in the place of x, if you in this place, so f of, if you input this value 1, so 2 into 1 will be equal to how much? 2. So this is mapped like this. Okay, so for 1 we have 2, for 2 we'll be having 4, for 3 we'll be having 6, for 4 we'll be having 8, for 5 we'll be having 10. Understood? So the function here is f of x is equal to 2x. For 1 we have 2, 2, 4, 3, 6, 4, 8 and 5, 10. Now what can you observe here, students? All the values of the domain are occupied, correct? There are no more values left out in domain. But in the codomain there are 2 more values left out. So that is not a problem. So whenever you see this type of function, okay, it is called as one function. Means each and every element in the domain has an image, or every element in the domain, so 1, 2, 3, 4, 5, or the pre-images here, has an image or codomain. So 1 has 2, 2 has 4, and it is not repeating. So one element of x has one element of y in the codomain, like that. So this type of function is called as an one function. So see 1, 1, like that. One function. Moving on to the next one. Many one function. So 1 function is generally represented like this. 1 function is generally represented like this. Okay, means one element here has one element here. Again, another element here has another element here, like that. So this is nothing but 1 function. Now, when we are seeing many one function, how to remember this, students? You have to remember it like this. Means two elements in X will be having one element in Y. Okay, so for example, let us take one example here. So let us take the values of X on this side. Let us take the values of Y on this side. And there is a function. So let f is equal to, or f of x equals to x square. All right. So on the left hand side, that is nothing but, what is this? A domain. Okay. So here we have -2, -1, 0, 1 and 2. On this side we'll be having 1, 2, 3 and 4. Okay. Now see this. In the place of x, if you put -2, so that will become -2 the whole square. What is -2 the whole square? It is +4. So mapping will be doing it like this now. So if x is equal to -2, then y is equal to 4. If x is equal to -1, y is equal to 1. If x is equal to 0, so again we'll write 0 here. So y will be equal to 0. If x is equal to 1, see this, y is equal to +1. If x is equal to +2, y is equal to 4. See these both lines? Correct? And see these both lines? And see this. This is called as many one function. Means one or more elements in X can have the same image in Y. So for example, -2 and 2 are the elements of X. What are the images in the Y? Same image, that is nothing but 4. Why? Because the function is nothing but x squared. Similarly, -1 and +1, two pre-images in X has the same image in Y. So that is equal to +1. Why? Because the function here is x squared. And 0 is having only 0. Understood? So this is nothing but many one functions. Means one or more elements in X has the same element in Y. So pre-images and one common image for two pre-images. So this is many one function. So just remember this sign. Okay, you can understand many one function very easily. Okay, moving on to the next one. Surjective function. So before this we saw injective function, right? So what is injective function? Injective function is nothing but one function. So we'll just go back. One function is nothing but called as an injective function. So what is very important here is every element in X has one element in Y. Okay, means X must be occupied. So here we'll write again, X must be occupied completely. See, all the elements of X are occupied. So, but see, these two elements of Y are not occupied. So this is fine. If all the elements of X has the image in the Y, okay, all the elements, none of them should be left out. That type of function is called as one function. We also call it as injective function. The inverse of this means all the elements of Y should be having the pre-images in X. So that type of function is called as surjective function. So for example, we'll see. So what do we write on onto function here? So here we'll write every element of Y must have pre-image in X. Understood? This is called as a surjective function. So for example, we'll take the value of X and the value of Y. So here we'll take the function f equals, or f of x equals x plus 1. Alright, f of x equals x plus 1. So here we'll write 3, 4, 5, 6, 7. Okay, f of x equals x plus 1. So here again we'll write 1, 2, 3, 4, 5, 6, 7, 8, 9. Now see the students. Okay, this is 8. So now if you put x is equal to 1, you will be getting 2. Do we have 2 here? We do not have any 2. If you put x is equal to 2, then we'll be having 3. So see the mapping now here again. So now 2 and 3. Okay. X is equal to 3 will be having 4. 4 will be having 5. 5 will be having 6. 6 will be having 7. See what is happening here? These elements are left out, as well as this element is also left out in the place of x, which is already written in domain. But all the elements of y are occupied, right? None of the elements are left out here. 3 is occupied. What is the pre-image of 3? 2. Pre-image of 4? 3. Similarly, 5, 6, 7 also has their pre-images. So this type of function is called as surjective function. Now there is another function whose name is given by bijective function. So what is bijective function? Injective function plus surjective function. So this type of function is called as a bijective function. So bijective function will be seeing in the problems. Okay, so just remember this, bijective is nothing but injective plus surjective. And what is surjective or onto function? All the elements of y must be having a pre-image in x. Alright, moving on to the next. Composition of a function. Now in composition of a function, so for example, to understand this, so we'll take x, y, and or else we'll take f, g and h. That would be better. Okay, so from here till here it is. So this is x. Okay, so this will be f of x, because here we are having f, and from here to here we'll be having g. Nothing but students, f, how we have f there, similarly we'll be having g. So this will become g of f of x. Okay, so now what is f defined by? So f of x, let us write here, f of x is equal to x square, and g of x will be equal to x plus 1. Okay, x plus 1 and x square. So let's write down the elements here. We'll take very less elements, 0, 1, 2, 3. Alright. So what is 0 square? 0. 1 square is 1. 2 square is 4. 3 square is 9. Understood? So now from here again, what are the values of x? X is nothing but 0. So g of x, so that is nothing but g of f of x. Understood? So g of f of x, how can that be written? It can be written like this. G of f of x. Now what is g of x, students? First of all, what is g of x? See here, x plus 1. Just write x plus 1. What is f of x here? See what is f of x? X square. Here we had x. See this one. Here we had x. So in the place, in this bracket, what we have written x, right? So in this place, what should we write? X only. Okay, now if I have to write g of f of x, what do I have? Here I had x in the bracket, so I have written x here. Now I have f of x. So in the place of x, what should I write here? In the place of x, we have to write f of x plus 1. Understood? Now what is f of x? F of x is nothing but x square. That is nothing but x square plus 1. So this is nothing but composition of a function. What is the meaning of composite? This is the composition, right? So what is the meaning of composite? What is the meaning of composite? Very simple example I'll give. Okay, for example, you all know this Maggi, correct? So Maggi is a 2-minute snack which is available in India. So Maggi is a composite meal. What is the meaning of composite again? Composite means it is consisting of 2 or more elements. So what are the components of Maggi? So first of all, the noodles, the Maggi noodles, then we add water, then we add the taste maker. So 3 things. Okay, the noodles, water and taste maker. There are more than 2 things here, correct? There are more than 2 things. So that is why it is called as what? A composite material, which is made up of 2 or more elements. So this is nothing but composition of a function, means function only, but having more than 2 or a 2. So composition of a function. So now coming back to this, in the place of x you put 0, you'll be getting 1, you'll be getting 2, 5 and 10. G of x, f of x and x, composition of a function. Okay, so on to every y must have pre-image in x, many 1, remember this symbol, 1 1, every x must have image in y. So this is the summary of today's class. Apart from this, we have 2 more topics to be done. So the last 2 topics in functions, so that is nothing but binary functions and one more is invertible functions. So after these both topics, okay, this will be the end of functions. We'll be starting the problems very soon. So that's all for today, students. I think you have understood whatever I have told. If any doubts, please do comment in the comment section. Thank you and subscribe for Vista's learning.